Hello, Bahia. How are you today?
Hi, how are you?
Okay.
Good. Looks like it's just the two of us today.
Yeah, well, I just see somebody else dropped in,
Okay.
and then there's a couple of classrooms connected, so it's hard for me to tell if there's anybody in there.
Okay.
Now, just some maintenance. I think that after this module, we'll do one more module. These annuity ones are very tedious. I'll write the formulas are really ugly. Once you get all the formulas down, if you're careful on how you enter the numbers, not too bad, but they are time consuming. So I will make sure I get all those. Did I write in the first 5 questions, did I write the formulas for the annuity due and the ordinary annuity beginning and end of the month thing? I may not have. That's the end. Well, I'm going to go ahead and write it out again just to make sure. But we're going to start on number 6 here. And we may only get another 5 questions in because number 6 starts with another formula. And like I said, we will only do through investments, module 7. That's a lot because we have also, besides the 3 of us that are sitting here, there's, I don't know, 10 or 15 online students who have to finish as well. So if we take the next couple of weeks finishing up annuities, that'll take us probably into Thanksgiving break, so then one more will take us up to just about into the first week of December or so. So that's about where we should be ended. 7 modules, 7 tests, all equally weighted. So your final grade is the average of those 7 tests. And it's just the tests. And I need to post another video announcement about this or something for the people who came in late. It's just the tests that are part of our regular Canvas. Somebody came in later and stuck in all this start here stuff, and I hid it all, but I don't know if they sent you anything else. It's just a bunch of junk, and they dropped it right in the middle of the term just to make things more confusing. And it worked. It did make it more confusing. So anyway, we'll just go through our module 7, and none of that other stuff matters.
So we won't be doing module 8?
No.
Okay.
We will not be doing module 8 because this module is going to get pushed back. And I talk a lot slower. I'm sorry. So everything slows down a little bit.
I got you.
All right. Thank you for you guys have been very understanding. I talk slower and get winded a little faster than I used to. So, but that's not bad. I think we did pretty good. Anyway, let me just write these first 2 formulas down so you have them. Even though I think we may be done with them in the first 5 questions. Let's see. And excuse me if I've done this before. Annuity. Yeah. Annuity due. And these were recognized because they were payable at the beginning of the month. Annuity due. And they always made a point of capitalizing beginning. And that formula looked like this. The future value of the annuity equals the amount we were putting in every month 1 plus R, which was the rate, raised to the n power, which was the periods, minus 1, all over the rate again, times, when you were done, 1 plus R again. And this is the only difference in the two formulas. And that's because we're starting payment at the beginning of a month instead at the end. So you get that one extra month then, and that makes up for that. Ordinary annuity. And they always made a point in the problems to let us know that this was payable at the end of the month, or we paid our payment at the end of the month. So it looks a lot like the other one. And I think last week we missed because I think that was when my power went out. And I'm sorry that happened. It happened right in the middle of the class before this one. And it actually came on later in the afternoon. And I don't know what in the world went on because it wasn't a mass outage. I looked it up after it first went out, and it was really just concentrated right here in this little dinky area that I live in. So I'm not sure if someone hit a pole or shot at a transformer. I live out in the country, so you never know what people are going to shoot at. But it was down for a couple hours, and that was it. All right, so this one just looks like that. Give you a minute to go this down, and then we'll move to number 6 with some new formulas. All right, so here are the new ones. A payout annuity formula here. And you'll see what kind of problems fit these. And I will define all the letters too, what all the letters mean. Okay, so P equals D1 minus 1 plus R divided by K. It's hard to find formulas much worse than the ones you run into in business math. And the exponent is actually a negative exponent. N times K. All divided by R over K. So really ugly You have to be very careful. Put them in on your calculator. And I'll put these in and you'll see how I put them in on the calculator. And hopefully that'll help you. P is our beginning amount. D is our regular withdrawal. And you don't have to save all the test questions until we're after the review. If you want to start on the test, you can do the ones that you know how to do and then come back to it later. You don't have to finish it all in one sitting. So you could do a few and then you get up to one you don't know. You can just wait until we go over it if you want, because 15 of these questions does turn out to be quite a bit of work. Annual interest rate. And you know how that goes. We usually have to divide that down depending on how it's compounded, semi-annually or whatever. But the R is the annual. And then the K takes care of the compounding. That is our compounding periods in a year. So if it's compounded semi-annually, that would be 2. And you've done that in previous modules. Compounding periods. Come on, pen. And then finally, N is the number of years. There we go. So let me let you get that. And then we'll try to do 6 through 10 today. Today.
I think I'm good to go.
All right. Let's go then. Annuities practice quiz. The test may not have as many questions, hopefully.
Okay.
All right. We went through 5. All right, so here's a question that will solve with that new formula. Suppose that your bank pays 10% interest, compounded semi-annually, so that's twice a year. We're not going to worry about the table. Find out how much should be deposited now to yield an annuity payment of $400 at the end of every 6 months for 4 years. So you're retiring or something like that in 4 years, and you're like, I'd like to be able to withdraw $400 out every 6 months after I retire. So how much should I stick in the bank now, which will guarantee me those payments? That's $400 payments every 6 months for 4 years. So that's what we're going to do. And using our formula, our P is going to be the amount that we pay in, which we're solving for. And $400 times 1 minus 1 plus the interest rate, 10%, 0.10, divided by the number of times it's compounded in a year, which is semi-annually. So that's 2. And the number of periods is twice a year negative, twice a year times 4 years. So how many periods is that? If it's for 4 years and it's twice a year. So how many periods is that? It's well, it's n times k, so I could write it out. It's 8. No, there it is 8, but it's 4 times 2. It's 4 years times 2 payments. So it'll be a -8 there. On the bottom, 10% divided by 2. So there's our formula in all its glory with the numbers plugged in. And I know I brag a lot about this calculator, but it's really great. And the nice thing is when I'm done putting in a calculator, it'll really look like on this, what I'm looking at on my calculator will look like what I wrote on the screen. So if you write out where the numbers go, you should be able to see it on the screen that way. Easier said than done, right? Let's see. Let me get some of this toolbars out of my way. Okay, here I am. Graphic calculator. Okay, 400. And then I put in 3 parentheses because by the time I'm done, if you get 1 extra pair, that's okay. But I got 2 that I can see. Plus, I'm going to have to put it on the top of a fraction. So that usually means another one. 1 minus parenthesis. Like I said, I might have 1 more than I need, but that'll be okay. 1 plus 0.10 divided by 2. And then there's that. Then my exponent, I'm just going to put a -8 in, -4 times 2. All right, that's my whole numerator. That's the whole top of my fraction. So there's that. I'm going to divide that by, yeah, I think I got one extra set in there, but it's okay. 0.10 divided by 2 again. And there is what I get. So if you deposit 25.8529 today, then in 4 years, you can withdraw at $400 twice a year for 4 years. So is that one of the answers, hopefully, after all that? 25.20, there it is right there. Go back to the calculator and let you see that. Yeah, if it bothers you, we could take out a set of parentheses and close these off and make it look prettier, but it's the same thing. That was number 6. Number 7, right here. Robert wants to have $2,300 at the end of every 3 months for 8 years. The bank pays 8% interest compounded quarterly. Robert calculates the present value of the ordinary annuity, 53,97716. What would be the present value of the payments if he received them in the beginning of every period? So we had one like that. It looks really messy, but all you're really doing is switching from this end of year amount to the beginning, end of month amount to the beginning of the month. And to do that, all you have to do is multiply this by that little extra 1 plus, remember the 1 plus R, or in our case, the 1 plus R divided by periods. What was our period letter? Let's see. Number of years, compounding periods, K. So we can take the, instead of doing, if we plugged all this in that big formula, this is what we would get. And then to add, switch to the beginning instead of the end, we would just multiply it by this extra thing. So to save us the trouble, we can just take this, because they already did all that work from the last problem for us. Multiply it by 1 plus rate over K. And this one is 8% over every 3 months. How many periods is that per year? Every 3 months.
4.
Very good. So this is what we're going to do. And like I said, if you want to do this from beginning to end, you could. You could use that formula we had and plug all those numbers in, and it's going to give you this first 53,000 number. But they've already done that much work for us, so I can't really see the point of doing that again. We'll just do 53,97716 and multiply that times 1 plus 0.08 divided by 4. and I get 55,056.71. So that's how much we'd have to have put in the bank now to get that payout we're looking for. 55056. There it is right there. And I could add that to the, just so you have it here. See if I saw that formula. Yeah. Write it on here. Just now I've forgotten. Is that end of month or? This is the end. So, just so you have it on the record. For beginning, of period, multiply above by 1 plus, what did we use for rate R divided by K. So that'll cover that case where that happens. That took me a long time to figure out. I mess with that and mess with that, I'll tell you. Something so simple. So for beginning of period, multiply by that. And that'll cover that one. So now we have it on the Zoom. All right, now number 8. And here's an example of one that's beginning. So we'll have to multiply by that little extra. All right, so we have 8% interest compounded quarterly. How much deposit now for an annual to yield an annuity payment of $1,300 at the beginning of each 3 months for 2 years. So we want, it's number 8, $300. 1 minus 1 plus 0.08. That's our interest rate. Now it's 4 times per year, right? Compounded quarterly. Now, how many periods do I have here? Four times per year times 2 years. So that is 8. So our exponent's -8 every 3 months for 2 years. So that's 4 times a year for 2 years. right? And all that is over 0.08 over 4. And then all this is multiplied 1 plus 0.08 over 4. Yikes. Now, whether the 300 is on the top of the fraction or out in front of the fraction doesn't matter. The multiplication is the same, just so you know, because you might see it both ways. So I'm going to put a parenthesis in there in the front. 300 I'll try it with 2 parentheses in here. 1 minus 1 plus 0.08 divided by 4. All right, and my exponent is -8. -8. And that appears to be my whole numerator. Close that off. And then my denominator divided by 0.08 over 4 again. And there's that parenthesis. And then we are multiplied by 1 plus 0.08 over 4. Now, did I do that right?
Looks right.
Yeah. Is it 300 or 1300?
It is 1300.
Yeah, I think I wrote 300 in the calculator here.
Oh, yeah.
Yeah, I thought it was me. I was wondering where the 300 came from.
Yeah, nope, it was me. It's almost always me. So speak up. There we go. My sloppy notes here. All right, there we go. 1300. Everything else looks good. 97, 13, 58 or 59. There it is. Very good. %9 interest. This is number 9. Make sure I got the right place on my book. Here we go. 9% compounded annually. You want $800 at the end of each year for 10 years. So I would be putting in this number 9, $800. 1 minus 1 plus now this is just once a year, right? Yeah, at the end of each year. So one time a year. That makes it a little easier. We don't have to divide by anything here. 0.09. And for 10 years, -10. Divided by 0.09. Now that 0.09 is divided by 1, if you want to write that, but it's kind of, you don't really need to write that.
Yeah.
And that should do it. I say, yeah, this stuff is messy, but I always think about what poor people had to do this before calculators.
I know.
Can you imagine? Oh my gosh. I'd quit if this was my job and I had to do it all by hand.
Right.
Yeah, I'd
Mhm.
find something else to do. All right, 1 plus 0.09 parenthesis exponent -10. Flip over here, parentheses divided by 0.09 again. 5134. There we go.
Can you go back to the calculator real quick?
Sure.
Okay, I see what I did wrong.
Yeah,
When I
take your
tried
time.
to put it
Fine.
in, the 1 minus the parentheses 1, I
Yeah.
minus the whole thing. Okay, I got it. Thank you.
Sure. All right, last one. Now they call this a sinking fund, but it's the same thing. It's when, if you own a business, you operate a business and you have kind of an expensive piece of machinery that occasionally has to be replaced. You want to be prepared for that. Because if you don't budget for that and you get a big, in this case, $25,000 bill, that might be kind of hard to swallow. So they start saving ahead of time. And they figure in this case, Hot Wheels Depot, they need to accumulate $25,000 in 6 years to purchase new equipment. And what payment would they have to make, excuse me, at the end of every 3 months? And they're getting 8% compounded quarterly. So how much would you have to save every 3 months at 8% to end up with $25,000?
Mhm.
Yeah, exactly. Now this one's going to, it's actually asking for something different in the formula. Let me just show you here. You share whiteboard. It's using this formula, but what they're asking for, let's see. No, I'm sorry. It's using the previous formula that I already wiped out. So I'm going to wipe this one out and write this for you. It is using the formula before that said, I don't know what a future value is equal to the amount we're paying in every month times 1 plus 0.0, well, not 0.08. I'm writing it from a, let me go look at my, oh, here. Let me look at my formula. Future value. Here we are. 1 plus the rate divided by the periods. Raised to the number of years times the periods. So this is the previous formula that I wrote down at the beginning, I believe, -1. Like that. The only thing is, when we did these before, we were looking for this, the future value of the annuity. Now we're given the future value of the annuity. We want that to be $25,000. What we don't know, or what we want to find out, is this number. What's the monthly amount we put in? So to find that value, you have to do just a little bit of algebra. In other words, you have to divide both sides by this ugly thing right here. So the amount we're going to put in every month will be this future value, just with a little algebra 1 here, all divided by that stuff in the circle. And it'll be a little easier to see when we actually do the problem. So we took that other value, and now we're solving for the payment amount. And because we're given the future value, we know what we want to end up with. We need to know how much we need to deposit every period. So let me write this out with the numbers in there. Well, let me get you can get it down. It'd probably be a little easier to see with the numbers in there. All right, so let's try plugging those numbers in. Looking on my page, the 20, what we want to end up with is on top. In this case, we want to end up with $25,000 to replace our equipment in, what, 6 years? And all of that is divided by one plus 0.8, the interest rate. And how often is it compounded? Every 3 months. So that's 4 times a year. Now, if it's 4 times a year for 6 years, how many periods is that?
4 times.
6 times 4.
It's 24.
Oh, good, thank you. I don't want to look like that decimal there, so there we go. So 24 periods. Good. And -1 all over 0.08 divided by 4. Looks messy. Yes, it is. $25,000 divided by, give me a few extra parentheses there. All this stuff. 1 plus 0.08 divided by 4. Raised to the 24th power. Minus 1. And then that is all over 0.08 divided by 4. So does that look right? I think that matches.
Yeah.
What I wrote over here. So $821.78. This is what I get. So you can see the value in that. If you're running a business, a $25,000 payment, sneak it up on you, may be hard to manage. But if you start 6 years ahead of time, then every 3 months, you just set aside or save at these interest rates, $821.78. And then at the end of 6 years, when you need the $25,000, you got it.
Okay.
So that's the value in that. And there it is. They call that a sinking fund for whatever reason.
Okay.
All right. Do you need to see the calculator again? I shouldn't have jumped off that so fast.
Thank you. I got it.
All right, good. So I think that it for today. We'll do the last 5 next class. And let me just see how many is on the test. Hopefully it's not as many, but it could be. 15, when you make a test, 15 questions doesn't sound like a lot. But for this module, it is.
Mhm.
But like I said, you can start on it now and even have half of it done before next class or more.
Okay.
If you want to.
Yeah.
Just I had to do the practice, I had to take it in little bites. It was working through some of this was fun adventure.
Okay.
Woody's test. Oh no. 18. Oh my gosh. Did anybody start on the test yet? Probably not.
Not yet.
All right, let me go in and reduce the size of that.
Okay.
Because no one's going to fight me on that, are they? That's just too much. Let's see. So I'm going to hide the test, and then I'll go in there and delete some of the questions and shorten it significantly. Here it is. All right. So I'm just hitting the test for a little bit until I can get in there and edit it, and I'll shorten it quite a bit because that's too much. So, but anyway, next class, we'll finish the practice and I'll make sure I have the test shortened so you'll be ready to go.
Okay.
But I
Sounds good
appreciate-
to me.
Thank you all for coming today,
Thank you.
and I will see you next week.
Okay. See you next week.
All right, bye.
Bye-bye.
Bye.